All right, let's go over this review. Make sure you've got all your components and you understand what's going on with our hypothesis test for one proportion. Okay, so we start with this problem. I actually thought that this little piece right here, this having at least 96% of the customers succeed, that was kind of a confusing question that added. I was wondering, what are we really trying to figure out here? And that kind of played into the fact that P is the proportion of people who are successful at setting up the features on their smartphones. And so their goal was this null hypothesis of having at least. So it was kind of a greater than or equal to, but we don't ever do the inequality. We just go ahead and say, okay, the goal is we're going to set it at 96% and see if they have failed to meet that goal, which would mean that they had gotten significantly less than. So that's what led us to have the less than for our alternative. Now, as you read through this, then you see this word 4% significance level. So again, that significance level is what's going to, if they tell you a significance level, so that's the language you're looking for, then that tells you alpha is something other than the default of 0.05. Okay, so they identified that here. All right, so make sure you get all the parts of your statements. Null hypothesis, colon, P equals 0.96, and HA, colon, P is less than 0.96. So now we get our p-value, and this population proportion is always that hypothesized value. This is the same. Our sample size was 200. And so then we had our standard deviation, I think was 0.01385 or something. So I do this to two significant digits for standard deviation and z-scores. So 0.014. So the sample results, remember p hat is the sample results. So we got 188 out of 200, which is 0.94. So that's what our sample was. So our sample is less than 0.96, but is it significantly less? Okay, so does that give us evidence they have failed to reach the goal? Or could that 0.94 be just because of sampling variability? All right, so our z-score. See how far the sample results we got, the 0.94, are away from what they're supposed to be, the 0.96, in terms of the standard deviation. And so then the norm CDF component, that's what is giving you that p-value, the area in that tail. So that's 0.0764. I kind of got to where because I wanted to make sure that this comparing of my p-value to alpha was a decimal, I kind of skipped this little interpret the p-value for a minute. And I come on down here and I say, okay, let me go ahead and compare my p-value to alpha while I have it as a decimal. So my p-value was 0.0764, which is greater than the significance level of 0.04. So if the p-value is greater, then I am failing to reject. I'm not going to reject. I'm only going to reject if that p-value is low. If the p-value is low, reject HO, and I don't have that, so I fail to reject. So remember this, if I fail to reject, then this null hypothesis statement holds. I'm not saying that's true, so don't tell me that the null hypothesis is true, and do not tell me that I accept the null hypothesis. No, I just did not have evidence to reject it and determine that P is less than 0.96. So that's how I said that here. There is not evidence that the proportion of people who are successful in setting up their smartphones is less than 0.96. So I do not have evidence that the company has failed to meet their goal. Now, let's go back up and kind of come back here to this part I had left off, the interpretation of p-value. So remember, we kind of are turning this p-value, moving the decimal twice, 7.64%. So remember that the visual to help you, the p-value is the probability of getting this sample or something more extreme if the null is true. So if this is true. All right, so now let me put that into context. There's a 7.46% chance of getting 188 out of 200 people who can successfully set up their smartphones if the success rate is still 0.96. Okay, so that's what I have here. Remember, these are the three parts that we are going to be checking. So there's a 7.64% chance of getting 188 of a sample of 200 people who are successful at setting up their smartphones if the true success rate is 0.96. All right, next. So this is saying that the proportion of the nation that is obese is 34%. And we are then asked, we are wondering if this particular county is better, is less than, because we are wondering if this sample gives us evidence that the 34% figure is too high, meaning they're hoping that the proportion in their county who are obese is less than that national percentage of 0.34. Okay? All right, so P equals the proportion of adults in this county who are obese. We start off with the null hypothesis being the same as the nation of 34%, and we wonder if it's actually less. So we get our p-value. So here is our p-value. Ooh, very small, because I got a z-score of negative 2.35. So when I norm CDF below that, get 0.0094, so very small. So remember, I like to leave this as decimals to when I compare my p-value. So I'm going to jump to there. I'm going to skip that, interpret the p-value for a moment. So my p-value of 0.0094 less than alpha of 0.05. Okay, so I think what happened, see up here, if I read, they did not give me a different significance level. Remember, that's the key words. So therefore, the alpha is still 0.05. Okay, so that p-value is low. So I'm going to reject HO. So if I reject HO, there is evidence of HA. So there is evidence that the proportion of adults in this county who are obese is less than 0.34. So good job, county. It does appear as though the 34% figure is too high for this county. So I looked and I specifically answered that question. All right, so back to that interpret the p-value problem. So if I move my decimal twice here, that's a 0.94% probability, very small. So there is only a 0.94% chance of getting this sample results, 228 of the 750 adults who are obese, if the true obesity rate is 34%. So that's what I wrote there. If that true obesity rate in the county is 34%, like the rest of the nation. All righty then. Last one, moving on. So this one caught a lot of people off guard. So we have this National Center for Education, who had conducted a study for elementary and secondary education. Their 2010 numbers are often used as the baseline to assess changes. And so in the 2010 survey, they had 34% of the students had not been absent. So 34% had perfect attendance. So that was great. So in the 2015 survey, the responses from 8,302 randomly chosen students. So what this is telling me, and so that number had grown to 35%. So this is telling me that this is the sample results. Okay? So these are the sample results. And then so that is what I'm going to compare to what currently was happening in the 2010 approximation or statement. Okay. And I'm going to see. So, see, that's what I did down here. See, look, the sample results were 35%, of the 8,032 students. So that was the sample results. That's what we were going to be using to test and see if the perfect attendance rate of the nation's students has increased. So P is the proportion of students who have had perfect attendance in the previous month. We're going to start off with our null hypothesis, saying that it's the same, it's what it was in 2010 of 34%. And then we are going to use that sample results to determine if we have evidence that the figure has increased. Okay. So we come down here and we put in our information. And again, what was different about our sample is it was as a percent rather than as the fraction. So here were the sample results. We got those sample results. Let's see how far they are away from what they were claimed to be. And that standard deviation was really small. So we had a z-score of 1.89. So with that z-score, when we get our p-value, our probability, we're going to norm CDF from 1.89 to 99. Pretty small. That's a small probability. But the catch is we were testing this thing at a very small level of significance, 1%. So that our data had to be really far away from our null hypothesis to be. Had to be a really small p-value, less than 0.01 to be significant. So I skipped that interpretation for a minute. And my p-value was 0.0294, which is greater than in alpha that they specified as 0.01, not the default. If you had put the default here, you would have rejected the null. But with an alpha of 0.01, we actually then failed to reject the null. So this null hypothesis, I'm not going to say it's true, but it will hold in place because I did not have evidence to reject it and say that the proportion of students who have had perfect attendance in the previous month has increased, has gotten greater than 34%. There is not evidence that the proportion of nation's children who have had perfect attendance the past month is greater than 34%. So it does not appear as though the perfect attendance rate has increased. Now, back to this little p-value definition. So here we go. Okay, so remember for my p-value definition, I want to go ahead and move my decimal twice here and turn this into my percent. So this is the probability of getting these sample results if the null is true. Okay. So there's a 2.94% chance of getting a sample of 8,032 children where 35% of them had perfect attendance if the true perfect attendance rate is still 34%. Okay, so again, there's a 2.94% chance of getting a sample where 35% of the 8,032 children had perfect attendance if the true perfect attendance rate is still 34%. All right, that is all three of those problems. I hope that you did well on those so that you will do well on your quiz for Unit 8 on hypothesis test with one proportion.